use different ink here. As we recall, like the lowercase, we apply the Laplace transform. We use the uppercase, or you can write something that make it different between the lowercase and uppercase. And Laplace transform of the lowercase y, or the solution y that we're gonna get at the end, represented by the capital, the uppercase y. So what we're gonna do, same process. We apply the Laplace transform to all terms. That's the first step. And then um, for the Laplace transform, I'm gonna put the note on the side again. If you recall, the Laplace of the x prime is, see the first order, is mean s multiplied by the capital X, okay, minus the s to the power 0, okay. This follow the formula and then multiply by x 0. And then it simplified to be x at 0 is 0. So it just turns out to be s multiplied by the uppercase x. And then the Laplace transform of the y prime. Same formula, s to the first power because the first order, multiplied by the capital Y minus s to the power 0 of um, the lower case, the initial condition y at 0, and y at 0 also 0. So then it just s the capital Y. Okay, on a side note here is kind of the prep work. And then um, for the number, for the number, if you have the the theorem handy, like from 7.1, to the Laplace transform of the constant 1 is 1 over s. That means the Laplace transform of 2 gonna be 2 times 1, which is 2 times 1 over s, or 2 over s. Okay, so as we apply Laplace transform to all terms, the first equation becomes, I'm going to write one more time. So 2 Laplace of the x prime plus the Laplace of y prime minus 2 times Laplace of x equals the Laplace of 1. And the second equation, the Laplace of the x prime plus the Laplace of y prime minus 5 Laplace of the x minus 5, the Laplace of the y equals the Laplace of 2. And then from the side notes that we apply the formula to each one. So the first one becomes 2 times the s capital X, and then plus the capital Y minus 2 the capital X equals 1 over s. Recall that the Laplace transform will change the function in t to the function in s. Okay, the second equation becomes s times the capital X plus the capital Y, and minus 5 times the capital X minus 5 times the capital Y equals 2 over s. Okay, and after that, we can see it's similar to the way that we did with the elimination method in 4.9. So we just regroup them, the x and x together, y and y together. So now it becomes the x and x, it's 2s, 2s minus 2 multiplied by the capital X plus the, this is s, I missed that. So s multiplied by the capital Y equals 1 over s. And the second one, same way, regroup x and x together. This is s minus 5 multiplied by the capital X. And for the y, gonna be, this is s, again, I miss it. So s minus 5 as well, multiplied by the uppercase y equals 2 over s. And then from this, we're gonna eliminate one of them. So we have to pick and choose. Now it comes to the process of what we did in 4.9 to eliminate one of them. But we just don't do with the operator D, but it's involving S. So the idea of this is to get down to either capital X or capital Y. And since the capital X is the Laplace of the X, or the capital Y is the Laplace of the lowercase y, when we get down to that step, we're going to apply the inverse Laplace transform. Okay. For this case, looks like, well, it's um equivalent, so it doesn't matter which one you want to eliminate. So let's eliminate y. Okay, if I eliminate y, I'm gonna make the coefficient of the y to be the same. So then I'm gonna multiply the first equation by s minus 5 and multiply by the second one by negative 1, and then I'm gonna add them up. Okay, add them up. Then okay, so copy that. So now I have s minus 5 times 2s minus 2 capital X plus s times s minus 5 times the capital Y equals s minus 5 divided by s. S gonna be everywhere. The second one is negative s multiplied by s minus 5 multiplied by the capital X minus s minus 5 the capital Y equals negative 1 times 2 over s. No, negative 2. Let me see. Did I miss anything? Let me see. I multiply by, oh, I have to multiply by negative 1s actually, because I have s here. So I multiply by negative s, the second one. I have s minus 5. I multiply by s minus 5 for the first one. Okay, let's see. So that's why the second equation has negative s times s minus 5, negative s times s minus 5, capital Y equals, and the second, the right hand side of the second equation becomes negative 2s time, negative s times 2 over s, and then becomes just negative 2. And then add these two equations, so the y will be gone. Okay, and now we just work on the x and the s. That's another, like, a lot of pieces in algebra going on here. So we have the common factor s minus 5, s minus 5, and then we're gonna add this and this together. Okay, so we're gonna have the 2s minus 2 and then minus s of the capital X equals, the right hand side we add the s minus 5 over s minus 2. Okay, and that simplify with having the common denominator s. So s minus 5 minus 2s, it becomes negative s minus 5. S and 5, they are similar, I'm sorry about that. So now we have the x with the coefficient, and the right hand side is in the fraction in the s term. So we're gonna divide both sides by the coefficient of the x. Okay, then the capital X is negative s minus 5 divided by the denominator gonna be the long expression. So s originally, and then with multiply by s minus 5 multiply by, and this one can be simplified as you see, to s minus s, that becomes just s minus 2. So we can make it simpler as the denominator in the product of s minus 5 and s minus 2. Okay, now when we come down to this, recall the x is the Laplace transform of the lowercase x, which is one of the solution that we are looking for. And next we're gonna do the inverse Laplace transform of both sides. of the capital X. Okay, that means we do the inverse Laplace transform of the right hand side. If we do the inverse Laplace transform, we're gonna break it down into partial fractions. So break it down one by one. And this problem on the right hand side, we have the factor s minus 5 and s minus 2. So we're gonna rewrite it as the fraction with the denominator s minus 5, denominator s minus 2. Okay, so since all of them are linear, so we're gonna need the coefficient or the numerator as the constant term. So we are going to find A, B, and C to make the sum of these three fractions the same as the original fraction from the problem. Transform of the lowercase x now in a partial fraction is negative 1 over 2 of 1 over s plus 7 over 6. So I treat the fraction as a coefficient, okay, for our convenience. And the second term is 1, actually for the b is the for the denominator s minus 5, we have negative 2 over 3. And for the denominator s minus 2, we have 7 over 6. Okay. And next, we're going to apply the Laplace transform to all terms. So we get the lowercase x as the negative 1 half, the inverse Laplace of 1 over s minus 2 over 3, the inverse Laplace of 1 over s minus 5 plus 7 over 6, the inverse Laplace of 1 over s minus 2. And then use the theorem from 7.1, find each one of them. So the first one will return the constant term, which is 1. Okay. The second is in the form of, I'm going to put the note here, the inverse Laplace of 1 over s is the constant 1. This is s not 5. And the inverse Laplace of 1 over s minus a is e to the at. Okay. So for the second term, the a is 5. The last term, a is 2. Now we have the exponential for the last two terms. Now we negative 2 over 3 multiplied by e to the 5t. And the last one is 7 over 6 times e to the power 2t. Now we have one of the solution comes out. Okay. And then we're going to do the next using the relationship that we saw from the problem. I'm going to copy. Let me go to the next page and write out what we have. So x on the at the corner here. Remember, x is a function of the t. So x is negative 1 over 2 minus 2 over 3 e to the power 5t plus 7 over 6 e to the 2t. Set it aside. Next, we're going to find y. So the solution y, right? So to find y, have to go back to the differential equation. Which one is convenient to solve for y? The convenient one, well, since we're still dealing with the Laplace transform, we're gonna go back to the Laplace transform version that we did earlier. Okay, let me go back. For this step, the case before we eliminate the y, your goal is to find the y, right? To find the y. Let me do the highlight. Hopefully it works. Let me try. Yeah. So your goal is to solve for y. To have the less complicated one, we would use the one which has the less term that we have to work on for the y. So I'm gonna choose the first equation. As you see, only one term has y. Actually, the coefficient is simpler than the second one. So that's why I choose this equation. Okay. So we're gonna copy the first form, the first Laplace transform the Laplace transform of the first equation, and then look for the y. Go back. So from what we have, which is the 2s minus 2 times x plus s times y, this is s, equals 1 over s. So then the capital Y, you just move the terms over. So 1 over s minus, I'm going to change to the plus 2 minus 2s of the x. No, I don't want that. And then divided by s, which is multiplied by 1 over s. See the way that I did? I just did like move term over one by one, subtract both sides by the first one. When I subtract, I just apply the negative side to both terms. So then the position of the 2 becomes positive, and then the 2s becomes negative 2s. And then the coefficient s, I treat it as multiplied by 1 over s. Okay. Now, what we have, the capital X, that what we use, that what we have before we got the lowercase x. I'm going to put the note here. So the uppercase x is in the form of negative s minus 5 divided by s times s minus 5 times s minus 2. And what we're going to do, we're going to replace the uppercase x in there. Okay. Then the uppercase y equals, is a little bit messy, just bear with me. So gonna be 1 over s, I'm gonna put 1 over s out, and this make it 1 over s, then go 1 over s plus the 2 minus 2s, the uppercase x, which is negative s minus 5 divided by s minus 5, s minus 2, and this is plus sign, and bring them into one fraction. Another layer of algebra you have to deal with. So from the sum of these two, it has the s in there. See the s here as a common s, and then s minus 5, s minus 2, multiplied by 1 over s. Now s becomes power 2 for there. Okay. And the first one make the same denominator. So multiply top and bottom here by s minus 5, s minus 2, s minus 5, s minus 2. Then the first part of the numerator is the quantity s minus 5, s minus 2, plus the product of the last two there. So 2 minus 2 s minus sign. So this one can be changed to s, um, just treat it this way. So minus sign, so s plus 5. A little bit messy. Okay, more algebra term comes out. So simplify the numerator. You can use whatever the algebra, the computer algebra system to simplify or do it by hand. It can be done by hand, but just have to be careful. Okay, I'm gonna give you what I got for the numerator. Just save the time. So the top gonna be s square minus 7. the sim the the totally simplify is 3 s squared plus s, and then divided by s squared times s minus 5, s minus 2. Mm. So 3s squared plus s, which is s multiplied by 3s plus 1. And then we can simplify s and s. Actually, this is s squared originally. And then the power 2. Let me redo it real quick. I try to use different color, but it's just slow the process down. So 2 here. So one factor, the s on the denominator will be reduced. And then what we have so far is in the term of 3s plus 1 divided by the factor s s minus 5 s minus 2 as the uppercase y. Again, uppercase y is the Laplace of the lowercase y. Okay, lowercase y. That means the last step, the last process, we're gonna do the inverse Laplace, right? So we're gonna find the inverse Laplace of the capital Y to get the lowercase y out. That means we're gonna do the the inverse Laplace of the fraction 3s plus 1 divided by minus 5 and s minus 2. That means we're gonna find partial fractions again. Go ahead, you guys, put in the symbol lab and then tell me what you get. I'm gonna write out as the partial fractions to see the form. But then um, we need the coefficients of each fraction. I'm gonna write out as a divided by s plus b divided by s minus 5 plus c divided by s minus 2. And I'm gonna need A, B, and C. If you could help me out by those numbers, that would be great. Thank you. What you guys got?
I got 1 over 10s
1/10. Okay, so A is 1/10. And how about
plus 16 over 15
for the
s
B?
minus 5
Okay, thank you. And then how about C?
minus 7 over 6.
Okay, very good. Yep, yep. Thank you. So next we're gonna find um Andrew. Did Andrew just tell me those numbers?
Yeah, that was me.
Okay, thank you. So how about Noah and Josie? Did you get the same set of the numbers?
Yep, that's exactly what I got.
Okay, that's great. All right, thank you. So that next part, we're gonna do inverse Laplace transform. That means y is 1/10 times the inverse Laplace of 1/s, and the second term, which is 16/15, the inverse Laplace of 1/s minus 5. The last one, negative 7/6, the inverse Laplace of 1/s minus 2. And it turns out to be 1/10, and the inverse Laplace of 1/s is the number, the constant one, so multiply by 1, so just 1/10. The second term in the pattern of the inverse Laplace of 1 over 1/s minus a, same as what we use in the for the x part. So we have e to the at, right? In this case, a is 5, so gonna be plus 16/15 e to the 5t. The last one is negative 7/6 times e to the 2t. Now we get the solution for the y.